Hi everybody, in this first video on linear sequences, we are going to look at the table method to find the nth term of a linear sequence, and then we'll derive two more results that we can apply straight away to get this nth term. So let's start with the sequence 3, 7, 11, 15. You can notice that to get from one term to the next one we add 4, and the fact that this difference here is constant is characteristic of linear sequences. So let's start by writing these numbers in a table. The table we're going to use has 3 rows. The first one indicates the term number. The second one is for the timetable corresponding to the sequence. We'll see that later. And the last row is for the term values. So we see that term number 1 is 3, so we can write a 3 here. Term number 2 is 7. Term number 3 is 11. And term number 4 is 15. What we are interested in is the expression for term number n, so for the nth term here. So it's all about the expression that we'll find here in this cell. So we see that this sequence goes up in 4. So we are naturally going to compare it with the one-time table that goes up in 4, that is to say the 4 times table. So the 4 times table goes 4, 8, 12, and 16. You see that to get these numbers, we have multiplied by 4 every single term number here. So if we do the same for n, the general expression for the numbers in this second row here is 4n. Now that we have a sequence here that goes up in 4, just like the sequence we're working on, actually here really helps because you can see that the difference in between the second and the third sequence will always be the same. And you see that to get from the second row to the third one, we just need to subtract 1. This is why the general term here is going to be 4n subtract 1. So this 4n minus 1 is going to be the nth term of the sequence shown there. We got there in 2 steps. Step 1 was to find the right timetable that would go up or down in the same way as our sequence. And step 2 was comparing this times table with the actual sequence to find the common difference between the terms in the second row and the terms in the third row. Now that we found the nth term right there, we can try and comment on it. The 4 that we have here is coming from the 4 timetable that we needed, and that was coming from the fact that this sequence was going up in 4. So if you find that in a sequence the constant difference is add 4, you can expect the general term of the sequence to be of the kind 4n plus b. So now we need to interpret what this b is coming from here. You see, for us it's clearly minus 1. And if you look at the general term here, you see that the b is everything that is going to be left if this n here is equal to 0. So this means that you want to apply this formula here to term number 0. So if we extend our table of one column to the left, you see that the previous term would have been minus 1. So that the constant difference here is still 4. So you now have a very simple way to find the nth term for the sequence. The multiplier of n comes from the common difference, and the constant term here comes from term number 0. So let's now try and apply our findings to another sequence. With this sequence right there, you see that the sequence is going down, and that the term-to-term rule is subtract 2. So this means that we can expect the nth term to be of the kind minus 2 multiplies n plus a number that is going to be term number 0. If we extend the sequence of one term to the left, we find here like a 7. So the general term here should be t of n equals minus 2n plus 7. Let's check that our result is correct. If we go for t1, what we want to work out is minus 2 times 1, which is minus 2. Minus 2 plus 7 is 5. We find term number 1. If we work out term number 2, we go for minus 2 times 2, which is minus 4, plus 7 is 3. We find term number 2. So we can be sure that we have the right nth term. For those of you who would be interested in seeing the table method work on the sequence, there it is. So here we have the term number, including term number n, and here we have the term values, and this is what we are after. We see that the sequence goes down in 2, so naturally we are going to compare it with the -2 term table, which goes -2, -4, -6, -8. You can notice that because the sequence is going down, we need to use a negative times table. And now we can compare the second row with the third one here and see what's the difference in between these two terms. And you see that to get the third row from the second, we need to add 7 everywhere. As we were using the -2 times table, the term right there is -2 times n. And because we've added 7, we end up with -2 times n plus 7, which leads us to the exact same result as what we did at the very beginning.